All right, let's take care of some more examples where we need to rationalize the denominator. If I have 5 over, pay attention here, the cube root of 3, 5 divided by the cube root of 3. Okay? I'm not dealing with square roots anymore, I'm dealing with cube roots, which means if I'm trying to complete my picture here, I need to have 3 of the same factor. Right now I have 1 factor of 3, right? What's missing to complete that cube in that denominator?
2 more factors of 1.
I'm missing 2 factors of 3, right? If I just put in 1 factor of 3, what's 3 times 3? 9, but is that a perfect cube? No. So, however I adjust this, I'm going to have to use the same kind of radical, in this case the cube root. So, what am I going to put here?
2 cubed, 2, 3.
I need to put 2 factors of 3, and what's 2 factors of 3?
9.
That's 9. Okay? Because now, what's 3 times 9? So all of this stuff would give me the cube root of 27, which is just going to equal what?
3.
So my denominator now is the 3 free and clear. And what's in my numerator?
5 square root.
Not 5 square roots, but 5 cube roots
5 cubed roots
of 9. If I were dealing with just the square root, I wouldn't have used 9, would I?
Nope.
But the higher that index is, the more pieces you're going to need to complete whatever's there. Just let me give you another example that kind of relates to this guy. If I give you 7 over the 4th root of x squared y to the 7th z to the 13th. I'm introducing variables here. I've got to simplify this. I've got to be able to rationalize that denominator. So that means in the top and the bottom, I'm going to have to use the 4th root. Okay, now we got to think about this. For x squared, I have to have how many of the exact same factor? I've got to have, no, I have to have 4 of the exact same factor. How many do I have right now? I have 2. How many more do I need to complete this perfect 4th power?
2.
I would need 2 more, bless you. I would need 2 more factors of x. So if I do x squared, what's x squared times x squared? Bless you.
X to the 4th.
X to the 4th. And if I have x to the 4th inside the 4th root, won't that simplify away to give you something nice and clean? Just x, right? Now what about y to the 7th? With y to the 7th, I have 1, 2, 3, 4, 5, 6, 7 factors of y. How many factors of y do I need to finish that box? I just need 1 factor of y, right? So
Why is that?
because I'm making these boxes that have 4 of the same factors, so that's going to be something that's the perfect 4th power. Think about this. What's y to the 7th times y? It's y to the 8th, right? With those properties of exponents that we've talked about before. I'll put a 1 here. Maybe that'll make things a bit more clear. That's y to the 8th. If you do the 4th root of y to the 8th, think about what that would look like. Isn't that guy nice and clean? What does he give you? So I had to put in an extra factor of y so I could get something nice and clean out of that. How many factors of z do I need?
3.
Why 3?
Because 16 makes 4.
Right, if I have 3 more factors of z, then that would essentially give you something that looks like this. The fourth root of z to the 16th, and 4 goes into that exponent evenly now. That gives you z to the 4th. Okay. You want to make sure that whatever you have in your denominator at the end is something that when you take that radical, when you evaluate that, it goes away. It's nice and clean. So that means in my numerator I have 7 times the fourth root of x squared y z to the third. In my denominator I have the fourth root of what? When I multiply all this stuff together, what do you have? X to the what? I get x to the fourth, y to the 8th, 7 plus 1 is 8, and z to the 16th. When I look at my denominator here, and I looked at I remember the shortcut way that I was simplifying these guys the other day. Does 4 go into 4 evenly? Does it go into 8 evenly?
Mm-hmm.
Does it go into 16 evenly?
Mm-hmm.
So I created something in that denominator that's going to simplify completely outside of that radical.
So it's just gonna be X, Y, Z?
Well, I've got 7 fourth roots of x squared y z to the third. I don't have x, y, z in the denominator. What do I have? What's the fourth root of x to the fourth?
X squared. X.
I have x,
X,
y to the what?
Y,
To the second, and z to the what?
4.
And z to the fourth. See, I only put in what was necessary. If you look back at the original, how many times does 4 go into 7? Once, with how many left over?
3.
I'd have 3 left over, right? So I need to have 4 go into this evenly, so I just need to put in one more factor there, right? What about 13? 4 goes into 13 how many times?
That's where you come with 8 to get that y first.
Yes. Yes. So 4 goes into 13 how many times? With the remainder of what?
1.
I'd have 1 z left inside. How many more buddies would he need to be able to break out? 3 more, right? Because then you'd have z to the fourth, and that would match up with that guy. So that's why I put in just 3 more z's. That's why I put in just 1 more y. And when I've got this, there's nothing more for me to do. So if you think about this in terms of factors, you put in enough missing factors to complete the square, the cube, the fourth power, whatever it is, so that things can simplify completely out of that. Okay? I know it's crazy, but it's true.